So one of the main problems with designing rockets and stuff is the maneuverability during landoff and takeoff in the final bit. So here are some ideas to make this more doable in the future. One of the problems is with monopropellant hypergolic fuels. These are usually used in a wide variety of rockets for the final maneuvering thrusters and stuff like that in the final little stages. They're also used in outer space for maneuvering for slight changes. Now, compared to a solid rocket, you can turn them on and off much more easily. Liquid rockets you can turn on and off, but they take a while. With multiple fuels propellants, it takes a little while for them to turn on and off. But the liquid rocket with monopropellants are usually liquid, with multiple fuels that mixes and burns is much more efficient. So one way to make a hypergolic or self-combusting fuel monopropellant is actually you mix in the oxidizer and the fuel together, and you have them all dissolved at once. But this is a very dangerous setup because it so easily can explode. I'm wondering if you could design a rocket where you have it pre-mixed in many ways in a small chamber. Then you use this for some sort of maneuvering. Then you fill up this chamber with the two liquids, and then you mix it up, and you have some more monopropellant. That way you can get the higher thrust, and you don't have to store so much of really highly explosive material in the thing that could make the whole rocket go boom. One example also that could, and also by letting it have longer to mix, you can mix the proportions right better than if you had pumping in where you have to have all fancy things. So a big challenge in bipropellant ones is actually also mixing it quickly in a chamber while it's combusting and everything. And this one you can have it mix over a longer path, minutes or hours, and slowly get a more even mixture. An example of this that could be very simple is you have this hydrogen peroxide. This is an oxidant and it's H2O2. It looks kind of like a hydrogen, two oxygens bonded, another hydrogen. So if water is one hydrogen, each hydrogen is attached to one oxygen, and alcohols can mix very readily and easily. Another example is a lot of strong acids can mix with a lot of also oxidizers, and they can mix with a lot of organic materials in explosive combinations, and they dissolve in each other. So another idea that I've discussed before, much more than that, is a spark plug rocket where we can ignite the bipropellants really quickly using a spark plug, and also that can vaporize into small droplets so it can more easily mix together. You have a complex startup. Then you can turn it off more easily by turning off the spark plug, because maybe the spark plug is actually necessary for it to combust, to split up to full power or something like that. Or it might not be as good as a monopropellant, but you can have a more wide range, at least a faster start, and maybe it turns off, not completely off as fast, but has more of a cooldown. The third idea I just will develop more, but what I specifically mean by that is that with a lot of rockets and stuff, we have come up with better monopropellants, and we've come up with a lot better oxidizers, specifically the oxidizer end, but we haven't really researched them to actually build rockets. So lack of funding and us continue to do the same old stuff. So potentially you have a lot better monopropellants, a lot safer and also more environmentally friendly and less toxic, because a lot of monopropellants we use today are pretty toxic. We just haven't developed the exact rocket for them. And with every rocket with different fuels, you have to look at how to mix it correctly. So the mixing parameter is different, the pressure, the temperature, the reactivity. So this is putting a lot more funding into and also how you store the fuel, transport. So this is putting a lot more money into developing an actually good system. Another one I want to bring up is to develop a liquid rocket, but instead, part of what happens with a liquid rocket is we have pumps that need to pump in the liquids really fast. And these liquid pumps, we can't just turn off on and off quickly. That's why I can't throttle fully the liquid rocket quickly. What if instead we had it not turn on and off the pumps? That also takes a long time to put the pumps out to maximum speed. That's why you see the burn-up sequence. So when you turn it down, you might not want to. It's hard to turn it back on, so you might want to not turn it down, even though turning down is easier. Fully, is that instead the pump could be used to either spray more. You can redirect some of the fuel oxidizer to side jets for maneuvering it more, so little jets on the side to help balance out or just waste energy. In some cases, which might save you weight and stuff, so it might not be as a waste, and these ones already work more efficient and fast response. Or you can pump some of the fuel oxidizer back into the fuel and oxidizer tank, or use a pressurizer fuel and oxidizer tank itself, so you can gimbal it more. Now, certain pressure changes also in the nozzle could cause damage to certain nozzles, or if it's running too low and the gas expands too much and it causes shockwave. So this has to be complex design, and it can't be in some ways maybe as controllable as a monopropellant. And some of these ideas are not, so you might have to combine it, and some of these ideas are not mutually exclusive. You could, for example, combine this with my spark plug rocket idea. Another idea is that you could have it pumping different fuels to lower, and some of the fuels might be less powerful fuels, or acting more as a coolant to lower its ability to move, but you can use the same rocket engine for mobile things. Another idea along this whole line is to have what I'm going to call a multi-jet. And the multi-jet would work by shooting out multiple, multiple nozzle, but within the rocket engine you have a nozzle that sprays out the oxidizer and the fuel to mix and burn. But if you had one that was more complex, you can maybe throttle it that it burns more on one side or less on, or mixes at a different point in that chamber to make it either have more or less power, or the power is not evenly distributed to help turn and maneuver the rocket. Another thing to bring up is to design a better gimbal system. Gimbals are things that themselves turn the rocket motors in various directions, so the thrust can be pointed in different directions. Now, you can design a gimbal that really moves stuff. The problem with the gimbals is they make the rocket weaker. At that point, they make it heavier. There's more chance of something failing or breaking, and the rocket engine could go crazy. It's hard to move something with a lot of force. If it's spraying out gas, it's hard to redirect it. And it also could cause a nozzle damage as hot gas hits it more and causes more pressure, the thing turning. So if you combine it with my other ideas, it might be more doable. Like if you put in temporary lower fuel that doesn't burn as much hot and stuff like that, so you can power, it might be easier to gimbal the whole thing. So that's one way of making the gimbals work better. But you can also design better motors and let some motors to do it. Better actuators with like flexural actuators, which can lead to more fine control with less power. There's also ways of making a force more one directional, with like diode setups they have. So they have like diodes now for mechanical ones with made complex things. Or you could have gimbals that have more complex locking things, so they can become more solid and not solid, with shape-changing materials or other complex designs that might also now be more doable with 3D printing itself. So this is also something really to look at. You can also lower thrust with gimbals actually by causing some of the by using the same engine, splitting it more outwards or just inwards, and that uses up some of the energy in non-propulsive methods. So, yet another idea is to have this whole thing have an inflatable surface. An idea about having this whole thing have an inflatable surface very much is that inflatable surface can slow down the whole thing much more, because the wider the surface, the more it is, but it can fit in a smaller space. It can also give you more maneuverability because you have a bigger thing to act as a wing or something that can slow it down more on one side without as much force. And if you can deflate something, you can make it so it drops faster, or reflate to make it slow down, and you can make it inflate more on one side or deflate more on one side, all for control. And also, slow something is, you also have more time to make error corrections, and less heat is produced by air friction actually. So even though there's more air friction, the thing is traveling slower, and the speed turns out to go up with the cube of the speed, go up with more than the cube of speed, the amount of heat generated. And heat also has over this when traveling slow has longer to dissipate for any other methods. So inflatable surface could really help. So another one idea is just to have a plane or something bring up everything, or something that is alternative to a plane, such as the cycle rotors I discussed before. Put some links to that, or the Seiki fin idea I had before. And a plane can work much more efficiently up until an extent in an atmosphere than a rocket can with less fuel, and it's more maneuverable and controllable. Now, but this is only on the ride up. It also won't work on the moon or Mars, of course, but it could cheapen the ride before that from Earth. Another idea is to spin the rocket, and spinning the rocket can produce much more lift than a non-spinning object, and it also can have a gyroscopic effect that can stabilize the whole rocket, and it can also cool off the rocket better, because different parts, you have more lift, which slows down the rocket, but different parts of the rocket are exposed to hot and cold parts alternatively, and the air moves more fast over the surface, cooling down it, and the hot one will be exposed to cold, and vice versa, with heat transmission. Another idea is to work more on water landings, which of course, again, only works on Earth. But the advantages of water landings are quite numerous, in that they means you can have a bigger spot to aim for the whole ocean. You don't have to be as gentle because the water absorb it. You have more shock spread over the whole entire craft. You can. It's also safer because it's not near land, so if something goes wrong and the rocket's unfortunately lost, it doesn't blow up a nearby village. So water landings might be the future. But a weird idea I have is, if we're able to make a spaceport, maybe making a spaceport that is actually, maybe make a spaceport that is actually a liquid thing for it to land on. Now, water evaporates off of many places, but if you use a more dense liquid, which might even have better shock absorbing properties, you might be able to do it and mimic it and make a flat surface instead of making a hole inside a elaborate thing with elaborate construction. Just dig a hole and pump in the liquid, basically. I also just thought of that also launching from a liquid is actually much more efficient, because launching from a liquid, if you launch it like a plane or something, you can have a very long runway, You don't need to make a sophisticated one-way. But that's if you launch it not straight up and down. So another idea is to use complex, that I've talked about before, is to use complex AI feedback controls that can work in a variety of manners. But if you have a non-linear function and you have a mobile controls that can give you the same thing, you can actually use that to feed in controls, step it back, and see how the whole craft responds, feed back into loop, and adjust stuff slightly so it gets into like this and so on. But with an AI, but with having its response being non-linear with the controls, with how much you feed back into it, you actually can make something that mimics the plane and go more in depth, and can actually do self-computation like machine learning within the actual system, which is kind of cool without actually seeing stuff. Then with that learning, you can actually make a better AI afterwards, after you get the data to learn stuff. And you can also do more complex ways when you have limited data and figure out stuff like you don't know all how air friction exactly factors in, so just a little bit and a little bit more until it works better. You can figure out the margins better. Another thing that could be done is to make better simulations for landing and stuff that takes into account the wider margin and stuff to make the whole things better. So our simulations ourselves are not the best yet. Yet another idea is to have the inflatable surface spin or have flaps that can cause it to have more lift by flapping and moving air in a way that makes more lift, or it gathers more air until it gets too much force and opens up. That's a bunch of air which can also help in cooling with a big burst of air cooling off the thing. Or a spinner that spins, that's inflatable because spinning stuff cools off faster as it moves more air across its surface and exposes to more air, and it kind of expands more outwards, and the spinning also causes lift itself. Or you could have a lot of little or you could have an inflatable one with more holes in it, and to some extent air that's pushed away also pushes out more air because the air gets pushed outwards and interacts with other air nearby. It kind of makes it more solid, like a sonic boom pushes out air. So I've also discussed using what I call fuel cell rocket, but combining fuel cell technology and rocket technology to be more efficient, and that could potentially turn on and off better with electric currents, and I'll link the link below to that one. You could use the fairings, which is what holds the cargo stuff, to actually use as air brakes, maybe so you have where they open up and slow down the whole spacecraft. Now that could save on some weight, so you might need less parachutes and stuff, or give you another thing to control it. You could have it also so when it lands, you have the human part of it split off, like in a lot of older capsules and a lot of capsules to it. This means the human one, you can make it have much more of a central landing or precise landing, or one you can just dump it off from more places. So this is just widely used oftentimes, but it's just another thing to bring up. Another idea is to make it so that the outer layer is more conductive than much more conductive than the inner layer. And that means that heat will first dissipate more around the outside of the craft. When heat dissipates over a larger area, it radiates off more and conducts into air more easily, so the whole craft gets cooler. But then insulation keeps from reaching the inside of the craft, so the whole craft can handle hotter temperature. Now, if you actually have alternative layers and it goes from more conductive to less conductive, more conductive, you can actually bend the heat kind of like around the craft more, even more. So having multiple layers of conductive and not conductive to get rid of heat faster away from crafts. Another one is the heat pipes. the heat pipes is excellent. Heat pipes are little tubes filled of a very conductive heat exchanger, usually copper if you want the best, but you can make out other stuff. And copper CNT composites have potential to be even much more conductive, or by over 100%, or carbon nanotubes, if you could remake it, could be tens to hundreds times more. Then you have a liquid which can carry more heat but not usually as fast. And you can put the liquid inside and make it so it's near its boiling point, so it can boils off and can carry more heat as it condenses other places, or that condenses on the surfaces of the material inside. Because the material is rough, it makes like a condensation thing. If you have heat pipes on a craft, you can also distribute heat more evenly throughout the craft and use it to cool down. You can even use some of the fuel and heat as a coolant and heat up and capture that energy back and bring it into the engines. Another idea is that before we enter really hard, you spray more as mixed in fuel or something, or over too much fuel, too much oxidizer, and you use that to have the whole craft covered in a thin layer, or make a thin layer of fuel or something, or as a liquid to cool off the craft as it re-enters. The last idea I want to say is to have something like a built-in Peltier cooler, which will work more efficient at high temperatures. And that is the idea that when you have a piece of metal, and that piece of metal gets and you have another piece of metal with a similar material, so you have two metals together that you use. If you apply electric current, you can make actually heat flow from one side to the other side. And one side gets really hot, while the other side gets colder. And it's usually not very efficient, but on a big surface of craft with very high temperatures, you could make it more efficient especially when there's a big thermal difference. So the armor craft is really heating up to a high temperature. You pump in that heat from the high temperatures, and it's already in the natural flow, but you just speed up that flow and it radiates off more quickly. This kind of the Peltier effect is really fancy. It kind of works by reverse of the thermoelectric effect, where you make electricity when you heat up material with dissimilar metals, and that's the reason why is that electricity is more conducted more easily than heat between the interfaces of some metals, because the metal atoms themselves kind of don't interface very well, so they slide past each other. They have different thermal conductivities, but the electricity goes through it, so that's like energy actually takes away something. And since energy wants to flow from high energy to low energy, it's easier for electricity, so electricity flows. I'm oversimplifying it, but now when we do it, we can use the reverse and play a heat and make heat travel in a certain direction by the electrons taking away some of the heat energy, actually, and moving it across more easily and not letting it go the other direction as easily. Also, something I forgot to mention about the spinning one and the human one is that you can combine them, because the spinning craft is not safe for a human being. But if a human being has a special model in it, they might have a special model in it that doesn't spin, but the whole rest of the craft is spinning. Well, thank you very much for listening. Please like and subscribe. Give episode 10 out. I'm trying to reach 1,000 subscribers a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Again, thank you very much. Goodbye.